In this video, we're going to check out data cleaning with Python, Pandas, and Lambdas. So let's dive right into Jupyter Notebook and see what this is all about. So when we think about resolving incorrect data collection with lambdas and functions, what we're saying here is we want to look at a data frame row to row and use custom functions to determine and clean and modify data. However, if you have noticed from last time's examples, let me scroll up and show you one. In the example from in39, in the first line, I'm again creating a grouped data frame object by assigning the values of df.groupBy, grouping by x, to grouped. I'm again calling in the second line grouped.aggregate, which allows us to feed in aggregate functions to the grouping. And again, we're feeding in a list of functions. The difference here is this time we're using a lambda function in place of a normal function object, or a callable in Python terms. And in this lambda function, we take a single parameter in the function signature. And so we're simply doing lambda x. As you can see from the highlighted text, we're only specifying one parameter, x. We're feeding this x through to numpy.standard deviation, and furthermore we are feeding in the degrees of freedom parameter, setting it to 1. So via lambdas, we can specify additional parameters to numpy's summary statistics functions, and that's how we alter the details of the functions we feed into aggregate. A lot of people you would see would do this. They would actually feed in all the aggregate functions in terms of lambda x, and simply do np.std and do this. So this technically runs the same, but because functions are first-class objects in Python, all we need to do is feed in this function as a callable and be done with it. So this lambda x colon np.stdx actually doesn't provide any additional value, but to confuse the reader on what this code is doing. So if you see code like this, make sure you turn it into a first-class call that is feeding in np.sum as a callable. The other thing we can do is to name our lambda columns. So here notice that in the lambda output, we see that the columns are automatically named as lambda between two triangular parentheses. We can leverage this information to use the rename call to rename these columns. Here in in37, in the first line I call grouped again, and in the second line we feed in our old friend aggregate, feeding in a list of functions np.sum, and a lambda function lambda x np.std with degrees of freedom parameter set as 1. In line 3, we pass in a rename call, feeding in a dictionary of how to rename the key with the value in the value. By feeding in this dictionary to columns, here we can see that we're specifying that the lambda column actually gets renamed to custom_std, and we can see the same reflected in out37. The other thing we can do is to use lambdas to filter the data frame. So here we're creating a data frame where the columns are integers and B column is a list of characters. If we print this df out, it's an 8x2 data frame. And in in57, what we're doing here is to find rows where the value of B has more than 2 instances. So what we can do is in in57, we do df.groupBy, grouping by the values of B, column B, and then filtering using a lambda function. This lambda function accepts one parameter x, and that is whether the length of x is larger than 2. By using groupBy, what filter feeds into the lambda is a list of values, which is why the length function makes sense. The other very neat trick is we can get some very good summary statistics off of the describe call by feeding this into a lambda. So here we've grouped with column A, and we've applied the lambda x.describe to describe the list that is grouped under each level. So here, the describe call gives us the count, the mean, the standard deviation, the minimum, the 3 quartiles, and the maximum across all 3 values of x. More generally, we can apply a function using the apply call to an axis of a data frame. So here we're creating a very simple data frame of 3 rows and 2 columns, and we can simply apply the square root function from numpy onto this data frame. In out61, you can see that this is a very neat square root result from out60. We can also apply a function where the function returns a tuple. Here we create a lambda function that returns a tuple of x0 and x1, and by specifying the axis being 1 and the result type being expand, we can get pandas to expand this tuple back out into 2 columns. And as you can see here, originally this data frame is named AB. And after we've applied this, because we've not supplied any column information, it has actually recreated the columns via the lambda call, returning a tuple and pandas expanding that tuple into 0, 1, which is the default naming for the columns. If we want to apply things element-wise, we should call df.applyMap. As you can see, in this instance, the lambda x plus 5 gets created and applied element-wise throughout df. And that's all there is to it. In the next video, we're going to look at the topic of text cleaning with string functions in pandas. I'll meet you guys there.